Hello everyone. In this lecture, which is section 2.3, I want to discuss adding and subtracting fractions. So let me start by motivating this by looking at a simple problem, and we'll actually draw a picture on how we add these two fractions together. Let's say I want to add 2/5 plus 1/5. So in a picture, right, I can illustrate, let me draw a rectangle here. I'm going to break this up into 5 parts. So 2/5 can be illustrated by shading in this piece right here. Right, so 2 out of the 5 rectangles are shaded, right? So 2 parts out of 5. 1/5 can be illustrated by shading in this piece. 1 out of the 5. So together, how much is shaded out of 5? Well, 3 pieces, right, are shaded out of 5. So 2/5 plus 1/5 must equal 3/5. Okay, so in general, how do we, you can see that from the picture, but how do we generally add like fractions together? So let me give you the rules and then we'll do a couple of examples on this. So to add, we can also include subtraction here, say or subtract. We'll start with like fractions. Remember, like fractions are fractions that have exactly the same denominator. So how do I do this? Well, I first add or subtract the numerators. So step 1 is add, or if we're dealing with subtraction, you subtract. The numerators. You use the given denominator, so you keep the same denominator. So I'll say use the given denominator. And then simplify if possible, right? You often have to simplify the final result. So simplify the fraction if possible. Often you're expected to write the final answer in simplest form, okay? Okay, so here, let's do some examples. So again, these are just going to be like fractions that we're going to add. And then once we have this down, then we'll talk about adding unlike fractions together. So for example, let's say I want to add 7/10 plus 9/10. Okay, so these are like fractions, right? They have the same denominator. So what do? I add the numerators together. Well, 7 plus 9 is 16. I keep the denominator, right? So 10. And of course, this can be simplified, right? You could take out a factor of 2 over 2. So right, if you think about it, remember 16/10 could be written as 8 times 2 over 5 times 2. So I can cancel 2 over 2. So this is just the same as 8/5. And that would be the answer. And notice here that it's an improper fraction. So if you wanted to, you could also write this as a mixed number. So I'll say or, and do you remember how to find a mixed number? You have to divide it, right? So I divide 8 divided by 5, so 5 goes into 8 once. 1 times 5 is 5. The remainder is 3. So the mixed number, the whole number part is going to be the quotient 1, and then it's the remainder over the original denominator. So it's either 8/5 or 1 3/5, depending on whether you're leaving it as an improper fraction or in some examples, you might be asked to write it as a mixed number. Right? Same thing, just depends on how you want the final answer to be. Okay, this is also true if you have more than, if you're adding more than two fractions together, right? So let's say I have 3/20 plus 1/20 plus 8/20. Right? They're like fractions because they all have the same denominator 20. So the same rules apply. I add the numerators. 3 plus 1 plus 8 is 12. I keep the denominator, and then I simplify if possible. In this case, yes, I can definitely simplify. 2 definitely goes into both of them. In fact, you might also recognize that 4 goes into both of them, right, evenly. So let's say you didn't see that at first. You could start with 2. Okay, 2 goes into 12 6 times. 2 goes into 20 10 times. But then recognize that 2 will still go in here. So 2 will go into 6 3 times, and 2 goes into 10 5 times. So really, we took out a factor of 4 over 4, right? A factor of 1, which is 4 over 4. And we end up with 3/5 as our final result. Okay, subtraction is the same thing, except we subtract the numerator. So if I have, say, 7/9 minus 5/9, I subtract the numerator. 7 minus 5 is 2, and I keep the denominator. And actually, that's fine, right? That's already simplified, so I don't have to do anything else. Here's another example. Let's say I have 3/4 minus 1/4. Subtract the numerators. 3 minus 1 is 2. Keep the denominator. And then I can simplify because 2 goes into both of them, right? 2 goes into 2 once. 2 goes into 4 2 times. So I took out a factor of 2 over 2. Remember, the other way to do this is you could find the prime factorization. Well, 2 is already prime. 4, right, if we do the tree here, factors into 2 times 2. So I can cancel the 2's. Remember, we always have a 1 there, so this is equal to 1/2. Right? But in many cases, you can just do it mentally, right? You can figure out what that simplification is mentally. What if I have this? 1/8 plus 4/8 plus 3/8. So in this case, I would add, right? So I have to add all the numerators. 1 plus 4 plus 3 is 8. Keep the denominator. And notice that this just simplifies to a whole number, right? 8 over 8 is equal to 1. So that would be my answer. Okay, so that's like fractions. How do we add or subtract unlike fractions? Well, basically, the only thing that's going to be different is we first have to make sure that we rewrite each fraction so that they all have the same denominator, right? We have to write them, we have to find equivalent fractions all with the same denominator. And usually we use the lowest common denominator as the denominator. You don't have to, but it typically makes simplification easier at the end. So let me write that down here. So to add or subtract unlike fractions. Here are the steps. Write the fractions as equivalent fractions. I'll say with the same denominator. And usually what you want to do is you want to use the LCD, the lowest common denominator, as the denominator. So we usually use the LCD. Remember, that means lowest or least common denominator as the denominator. Okay, once you've done that, you basically now are going to do exactly what we did if they're like fractions, right? Because now if they have the same denominator, they're essentially like fractions now. So now you simply add or subtract the numerator, keeping the same denominator. And then finally, simplify if possible. Okay, so let's do some examples of this. Let's say I want to add 5/6 plus 1/12. Okay, so first thing, we have to find the LCD, right? The lowest common denominator. Now, again, you might be able to just do this in your head, right? Just do it mentally. Say, okay, what's the smallest number that both 6 and 12 will go into evenly? Well, it's got to be 12, right? 12 is the smallest number that 6 goes into twice, and 12 goes into it once. So it looks like the LCD is 12. If you don't see that, then remember we can always work it out. Remember, the LCD is really equal to the LCM, the least common multiple, the lowest common multiple of the two denominators. And we know how to do that. We use the tree here. Right, we find the prime factorization. So 6 is 2 times 3. 12 is 2 times 6, and then 2 times 3. Then we take each factor, the greatest number of times it occurs in either of the factorizations. Well, 2 occurs once in this factorization, twice in this factorization. So I need to take the 2 twice. And then the 3 occurs once in this factorization, once in this factorization. So it's a tie, but still the greatest number of times is once. So I need to take the 3 once. And I multiply those together. And of course, I'm going to get 12. Okay. So I need to rewrite the 5/6 as something over 12, right? I need to find an equivalent fraction to 5/6, but it has the correct denominator that we want is 12. So I look on the denominator. I already have a 6. How do I get a 12? I need to multiply by 2, but I also need a 2 in the numerator because this has to be a factor of 1, right? I'm not changing this. I'm just rewriting it in a different form. And then finally, multiply numerators. 5 times 2 is 10. Okay. Sometimes people, once you get better and better at this, you don't have to do a separate step here. You could just squeeze in like a 2 over 2 here, knowing that you want 12. So that problem really now becomes 10 twelfths plus 1/12. Now they're like fractions, so I simply add the numerators, 11, and I keep the denominator 12. So that's my answer. So it's going to be 11 twelfths. So 5/6 plus 1/12 is simply 11 twelfths. Okay. Let's do some more examples here. Let's say I have 1/2 plus 1/3 plus 1/4. Okay, I want to add them together. I need to have the same denominator, and I want to find the lowest common denominator as my denominator. So, what's the smallest number that 2, 3, and 4 will go into evenly? And you can probably recognize that that's going to be 12, right? So the LCD in this case is 12. So here, let me do the work just by putting in the values right next to each number here. I need to multiply by a factor of 1 in each case, but I want the denominator to be equal to 12. So 2 times what will give me 12? Well, I need a 6 there, so I better put a 6 also in the numerator. Here I'm missing what, a 4, so I better put a 4 in the numerator. Here I'm missing a 3, so I better put a 3 here. Notice in each case I'm just multiplying essentially by 1, right? So I'm not changing the fraction, I'm just rewriting it. I'm finding an equivalent fraction. So now if we do this, 1 times 6 over 2 times 6 is going to be 6/12 plus 1/3 times 4/4 is 4/12 plus 1/4 times 3/3 is 3/12. So now I add the numerators. I'm going to get 13 over 12. Or if you want to write that as a mixed number, you could divide this out and you're going to get 1 and 1/12. And that's it. So we know that the original problem, 1/2 plus 1/3 plus 1/4 is equal to 13/12, or 1 and 1/12. Okay, same thing with subtraction. So if I have 5, 6, let's say, minus 1/8. First find, right, the lowest common denominator. So it looks like, let's see, it looks like it'll be 24. Here, let's work it out though. So remember, I can factor the 6, 2 times 3. I can factor the 8. That's going to be 2 times 4, 2 times 2. So I have 2's and 3's as my factors. If we look at the 2, it occurs once in the first factorization. It occurs 3 times in the second factorization. So I have to take it the greatest number of times it occurs in either of them, so I need to take it 3 times. The 3 occurs once in the first factorization, 0 times in the second, so the greatest number of times is once, I take it once. If you multiply those together, right, 2 times 2 is 4, times 2 is 8, times 3 is 24. So it is 24. So I want to rewrite both denominators as 24. So here I'm missing what? I'm missing a 4 over 4. In here I'm missing a 3 over 3. So this is going to be 20 24ths minus 3 24ths. And that ends up being 17 24ths, right? And I can't simplify it. How do I know I can't simplify it? Because 17 is a prime number and it doesn't go into 24 evenly. So that's the smallest, that's the lowest I can go. That's the best I can simplify that fraction to. So 17 24ths is the correct answer. Okay, here's another one. 5 6 minus 2/3. So again, mentally you can think about this. Okay. Lowest common denominator, right, is the smallest number that both 6 and 3 will go into evenly. And it looks like it's going to be 6, right? 3 goes into 6 twice, 6 goes into 6 once. So the first fraction is okay. I don't need to change it. I already have the correct denominator there. The second one I can correct by multiplying by 2 over 2. So this really becomes 5 6 minus 4 6. Now I subtract numerators. 5 minus 4 is 1, and keep the denominator. So it's going to be 1/6. Okay, here let's do an applied problem that involves subtracting or adding fractions. Let's say you're told a 7/8 inch nail was hammered through a 3/4 inch door. And the question is, how far did it extend from the door? Okay, so you might want to draw a picture, right? Let's say this is our door. Let's say we're looking at the side, right, of the door. And then we have a nail. First of all, let me give the dimensions here. So this door is 3/4, right? So this distance is 3/4 of an inch, 3/4 of an inch. And then we drive a nail through the door, and part of it's going to extend through the other side. So something like that. And the size of that nail was 7/8 of an inch. So the question is, what is this piece right here? Like how much extended from the other side of the door? Well, if you look at this, right, this is really a subtraction problem in disguise, right? If I take the entire length of the nail, 7/8, and I subtract the width of the door there, 3/4, what I'm left with is what's left over, right? That must be how much of the nail is sticking out of the other side. So really, this is going to be 7/8 minus 3/4. Now I need to write both fractions, right, as equivalent fractions with the same lowest common denominator. In this case, what is the lowest common denominator? Well, it's the smallest number that 8 and 4 will go into evenly, and that is 8, right? So I can correct, I'll write it again here. I can correct the 3/4 by multiplying by 2/2. So this is really 7/8 minus 6/8, and that's equal to 1/8. And of course it has units of inches. So that would be my answer. So 1/8 of an inch is how much it sticks out the other side. Okay, so that's adding and subtracting fractions. Now let's talk about adding and subtracting mixed numbers, which is really, it's very similar. Now there's a couple of ways that we can do this. So let me write this out here. So adding, we'll start with adding. Adding mixed numbers. So one way of doing this is working with the numbers as mixed numbers. Another way is converting them to improper fractions, adding them or subtracting them as improper fractions, and then converting back to mixed numbers. Either way is fine. I will show you both ways how to do this, okay? So let's say I want to add, let me just do this as a picture first. Let's say I want to add 2 1/4 plus 1 1/2. Okay, so as a picture, I'm going to draw 3 rectangles here. And then I'm going to shade in this whole thing, and then just this one piece out of 4. So really this represents, right, this picture represents 2 1/4. And then when I add so this is 1 1/2. Okay, notice that one thing I could do is I could, instead of breaking this up into 2, I could break this up into 4 pieces. So really, 1 1/2 is the same as 2/4. 1 2/4, right? So the half is the same as 2/4. So can you guys see from this picture here, if you add these, right? If I add the whole pieces, 1, 2, 3, I get 3. And then if I add these pieces, I'm going to get 3 shaded out of 4, right? It's always out of the whole. So really, this is equal to 3 3/4. Right? I have 3 whole pieces, and then 3 pieces are shaded out of the 4 for the fraction piece. Okay, so how do we do this in general, just using arithmetic? Let me give you the rules here. So to add mixed numbers, first step, write the fractions, so write the fraction part as equivalent fractions with the same denominator. And you really want to use the lowest common denominator again. So write the fraction parts as equivalent fractions with the same denominator. And you really want to write them with the LCD, just because it makes the simplification the least amount at the end. All right, then what you do, so once you've done that, you can add the fraction parts. Okay, then you want to add the whole number parts. And then finally, simplify if possible. And the one thing that we have to keep in mind is that the fraction part has to be a proper fraction. If it's improper fraction, we have to find, we have to write it as a mixed number and take the whole number part and combine it with the whole number part that's already there. Okay, so that'll make more sense when we do some examples, but let me write that out. So simplify if possible, and I'll put remember the fraction part has to be a proper fraction. Remember, a proper fraction is when the numerator is less than the denominator. Okay, so let's do some examples with this. Let's say I want to add 6 and 1/12 plus 4 and 1/12. Usually we set this up vertically, so I have 6 and 1/12 plus 4 and 1/12. Okay, remember the first part is rewrite the fraction parts so that they both have the same denominator, right? The lowest common denominator. Well, in this case, we're all set, right? They're both 12, so they're already like fractions. So now I can add the fraction pieces. So 1/12 plus 1/12 is 2/12. And then the next step is add the whole number pieces. 6 plus 4 is 10. But then you want to simplify the fraction piece, right? And it is a proper fraction, so we're okay with that. But it can be simplified because 2 goes into both of them. So this can be simplified to 10 and 1/6. And that would be the answer. Okay, so this is equal to 10 and 1/6. Okay, here's another example. Let's say I have, I'll just write this vertically from the start. 7 and 3/10 plus 6 and 9/10. Okay, so again, the fraction pieces have the same denominator. That's good, so at least they're like fractions. I can start with that part. So I add the fraction pieces. 3/10 plus 9/10, remember I add the numerator, so 3 plus 9 is 12, and I keep the denominator, so 12/10. Then I add the whole number parts. 7 plus 6 is 13. But notice here that 12/10 is improper, okay? In fact, probably what you do is you would simplify it first. So 2 goes into both, right? 2 goes into 12 6 times, and 2 goes into 10 5 times. So even if we simplify it, it's still going to be improper, right? So this fraction piece is improper. And whenever we write a mixed number, the fraction piece has to be a proper fraction. So how do we handle this? Well, convert this into a mixed number, just a fraction piece, the improper fraction piece. So remember, we just divide. So 6 divided by 5. 5 goes into 6 once. 1 times 5 is 5. I subtract. So this is equal to 1, and the remainder is 1/5, right? So what do I do? Basically, right now I have 13 6/5, which we can think of as 13 plus 1 1/5. Right? Remember, this means 13 plus 6/5. So that's the same as 13 plus 1 1/5. But now what we do is we combine the whole number parts, right? So 13 plus 1 is 14. So this is going to be 14 1/5. And that is going to be our final answer. So that's simply going to be equal to 14 1/5. Okay, let's do another one here. Let's say I want to add 17 3/8 plus 20 1/5. Okay, well here, I can't even add the fractions right away, right? Because I need to have the same denominator. So let's find the lowest common denominator. And you might be able to guess it. In this case, it's just going to be the product, right, of 8 and 5, because 5 is prime and 5 doesn't go into 8 at all. If we want, we can work this out, right? I could find the prime factorization. 8 is 2 times 4, and then 2 times 2. 5 is prime, so 5 is I can't do anything else with it. So then I have 2's and 5's as my prime factors. I need to take the 2 3 times, right? Because it's the greatest number of times it occurs in either of the factorizations. And the 5 I need to take once. So really I'm just multiplying 8 times 5, right? It's just a product of those two, so it's 40. So what I can do is I can correct. Let me write this again here. Once you learn this, right, you can do the work right next to the fraction itself. So if I want to get a 40 in the denominator, what am I missing? I have 8 already, right? So I need to multiply by 5 over 5. And here I'm missing an 8. I need to multiply 8 over 8. So now this becomes 17 15 40ths plus 20 8 40ths. Okay, now we can add the fraction pieces. Well, 15 40ths plus 8 40ths is what? 23 40ths. And then add the whole number pieces, or whole number parts. So 17 plus 20 is 37. And I can't really simplify 23 over 40, right? 23 is a prime number. It doesn't go into 40 evenly. So that's my answer. So this original problem here, 17 3/8 plus 20 1/5 was equal to 37 23 40ths. So that would be the answer. Okay, let's do one more addition problem. Let's say I have 9 2/3 plus 10 7/12. So again, I can't even add these directly, right? I need to first rewrite the fractions so that they have the same denominator. In this case, we can sort of figure out what the lowest common denominator should be in our minds, right? What's the smallest number that 3 and 12 will go into evenly, it's got to be 12, right? So the LCD is 12. So I can correct the first fraction by multiplying by 4 over 4. And the second one's okay, right? Don't even need to do anything to the second one. So this is going to become 9 and 8/12 plus 10 and 7/12. Okay, so now add the fraction pieces, right? 8/12 plus 7/12 is 15/12. 9 plus 10 is 19, right? Add the fraction pieces or parts and add the whole number parts. I can simplify the fraction part, right? So 3 goes into both of them, right? So this is going to be 19 and 5/4. I can take out a factor of 3 over 3. But notice that the 5/4 is improper, right? This is improper. So I needed to divide it. So this is 1, remainder of 1. So as a mixed number, 5/4 is 1 and 1/4. And then combine the whole number part with the 19. Right? Remember, if we do this carefully, this means, so 19 and 5/4 means 19 plus 5/4. But that's the same as 19 plus 1 and 1/4. And then you would combine the whole number part. So this would be 20 and 1/4. And that would be the answer. Okay, so that's how you add mixed numbers together if you want to work with them directly as mixed numbers. Let's talk a little bit about subtraction now. So it turns out it's similar. So I'll write that here. So subtracting mixed numbers is similar, meaning similar to adding, right? You subtract the fractions, subtract the whole number part, then simplify. So you subtract the fractions, right? You would do that first. Subtract the whole number part. Then simplify. The only issue that you might have is the fraction part of the number being subtracted. If it's larger than the fraction part of the other mixed number, then you're going to have to rewrite the fraction of the other mixed number. So let me just say, so I'll write it this way. I'll say, however, if the fraction of the mixed number being subtracted, I'll just say on the bottom, I'll keep it simple. If the fraction on the bottom is larger than the fraction on top, you need to rewrite the fraction on top by borrowing from the whole number. By borrowing from the whole number. Okay, and this will become more clear when we do some examples. So let me start with a straightforward example. Let's say I want to subtract 6 2/3 minus 1 1/3. Okay, so the fractions already have the same denominator, right? They're like fractions. So I simply subtract the fractions first. 2/3 minus 1/3, and I can do that because 2/3, by fraction on the bottom, I mean the mixed number that's being subtracted, right? And then this would be the fraction on top. Well, that's larger than that, so that's okay. So 2/3 minus 1/3 is going to be 1/3. And then I subtract the whole number parts. 6 minus 1 is 5. So that's a simple case, right, where it works out nice. Here's another example. Let's say I have 10 4/5 minus 2 1/10. Okay, so here I don't have like fractions. I have to rewrite them so that they have the same denominator. I want to find the LCD. Well, that we can do in our heads, right? We can do this mentally. What's the smallest number that 5 and 10 go into evenly? It's got to be 10, right? So I can correct the first one. Let me rewrite it. Correct the first mixed number by rewriting it right here. So I need to multiply by 2 over 2, right? And then minus 2 1/10. So this is going to be 10 8/10 minus 2 1/10. So now, again, I'm using kind of like straightforward terminology where I'm saying the fraction on the bottom. I'm not, if we're being careful, we should say like subtrahend and minuend, but it's just easier to say fraction on the bottom can't be larger than the fraction on top, right? And it's not. So fraction on top is larger than fraction on bottom. So that's okay. So now I can subtract these. So 8/10 minus 1/10 is 7/10. And then 10 minus 2 is 8. So it's going to be 8 7/10. Okay. What if I have this actually? What if I have, and then I'll do a problem where we do have to borrow. But let me do one more. Let's say I have 2 1/3 minus 2. What would that be? Well, because there's no fraction piece here, if you want, you could write one in. You could say it's 0 over 3, right? Keep the same denominator as the other fraction. And now we could do our subtraction. 1/3 minus 0/3 is 1/3. And then 2 minus 2 is 0. So this is simply going to be 1/3. It doesn't even have a whole number part. Okay? All right, let's do one now where we have to borrow. Let's say I have now 3 1/5 minus 1 4/5. Okay, one nice thing here is that the denominators are the same, right? So I don't need to find the lowest common denominator. That would normally be the first step. So they're already the same. They're already like fractions. But I can't subtract 1/5 minus 4/5, right? Because I'll end up with a negative, and we don't want to have a negative number here based on how we're doing this algorithm. So how do I make this one larger? What you do is you borrow from the 3 here, right? You decompose this. You rewrite it. So think of it this way. 3 1/5 is equal, right, to, if I borrow 1 from the 3, I could write this as 2 plus 1 1/5. But then if I write the 1 1/5 as an improper fraction, this is the same as 2 plus, remember how to convert that, right? 5 times 1 plus 1 is 6 over 5. And then if I write this back, it's not really a mixed number now, because it's kind of a funny way of writing it because the fraction is no longer proper. But in essence, you can think of it as 2, this is being 2 6/5. Okay, so these are really the same. This is the proper way to write the mixed number, but we need to write it like this in this instance because we want to do our subtraction. Okay, so now this problem now becomes 2 let me do it in black again. So this problem becomes now 2 6/5, right? That was the same as 3 1/5, but we borrowed 1 from the whole number part, minus 1 4/5. But now that allows us to do the problem, right? Now I can subtract 6/5 minus 4/5 is going to be 2/5. So I subtract the fraction parts and then subtract the whole number parts. 2 minus 1 is 1. So it's equal to 1 2/5. Okay, so that's why, that's how that works. Here's another example. Let's say I have 10 1/12 minus 4 2/3. Okay, I want to subtract those two mixed numbers. So here I do have to find the lowest common denominator. I have to rewrite those two fractions first, right? Well, it turns out the LCD in this case is going to be, I guess, 12, right? 12 is the smallest number that 12 and 3 go into evenly. So the first one's okay. I already have a 12 in my denominator. The second one I need to fix by multiplying by 4/4. Okay, so this is going to become 10 1/12 minus 4, and then 2/3 times 4/4 is 8/12. All right, but I can't subtract those fractions right now, right? Because the top, again, I'm using the terminology, top fraction is smaller than the bottom fraction, right? So I can't subtract. This one has to be larger. So we need to borrow 1 from the 10 here. So again, the way you want to think about this is 10 1/12 is the same as, I could write it as 10 plus 1/12, but that's the same as 9 plus 1 plus 1/12. Or I could write it as 9 plus, and I combine these two pieces. This is 1 1/12. And if I write the 1 1/12 as an improper fraction, this is 9 plus 13/12. So another way of writing 10 1/12 is 9 13/12. Okay, it's not the proper way to write a mixed number, but it allows us to do our subtraction here. So these two are the same. And notice I borrowed 1 from the 10, right? And that 1, because I have 12 as my denominator, that 1 is really a 12/12. So that's the other way of thinking about it, right? I borrowed a 12/12 from that 10, and I combined it with the 1/12 to give me 13/12. So now this becomes 9 13/12 minus 4 8/12. I subtract the fraction parts, right? So 13/12 minus 8/12 is what, 5/12? And I can't really simplify, so that's good. And then 9 minus 4 is 5. So that's my final answer. So this original question, this is equal to just 5 5/12. Right? The original question was 10 1/12 minus 4 2/3. We had to do all that work, and we found that ultimately it ends up being 5 5/12. Okay, now another way of doing this, so we worked with the mixed numbers directly, right? You could, if you wanted to, you could convert the mixed numbers to improper fractions. You could add them or subtract them as fractions, and then at the end, convert back to a mixed number. That's also a possibility, okay? Some people find one way easier than the other. It doesn't matter, whatever way you feel more comfortable. But let me do an example of that where we would convert back and forth. By the way, in the next section, when we talk about multiplication and division, that is the way that you want to do it. You want to convert them into improper fractions. It's much easier than working with them as mixed numbers. Okay, so let me show you an example of this. First of all, let me write that fact out. So you could also add or subtract mixed numbers by first converting both numbers to improper fractions. Then add or subtract the fractions and convert back to a mixed number. Okay, so again, you could also add or subtract mixed numbers by first converting both of them into improper fractions. Work with them as improper fractions, right? Add or subtract those improper fractions. Then convert the final answer back to a mixed number. That's another way of doing this. And whatever way you feel more comfortable with is fine with me. Some of my colleagues teach it just one way, but I'm going to give you like the option to do either way. So for example, let's say we want to add, here I'll do three numbers together. Let's say we want to add 1 2/3 plus 5 5/6 plus 3 1/4. Okay, but we want to do it this way where we're going to convert to improper fractions first. So first thing you want to do is convert these all to improper fractions. So what's 1 2/3? Well, remember how to do this, right? It's 3 times 1 plus 2. Here, I'll write it out here. 3 times 1 plus 2 over 3, right? Plus 6 times 5 plus 5 over 6 plus 4 times 3 plus 1 over 4. So this is really 5/3 plus, this is what, 35 over 6 plus, and then 13 over 4. Okay, so now they're all fractions, right? They're improper fractions, but they're fractions. We know how to add fractions together, right? We have to find the LCD. So, and you can probably guess what it is, right? What's the smallest number that 3, 6, and 4 will go into evenly? It's going to be 12. If you have to work it out by finding the prime factorization of each number, do it that way, okay? If you don't, if you can just do it mentally, that's fine, right? It's just quicker to do it mentally, but if you have to work it out, that's fine as well. So now I want to convert each of these, right? To make sure that their denominator is 12. So in the first case, I have to multiply 5/3 by, let's see, I need a 12, right? So I need a 4 over 4. This one I need a 2 over 2, because 6 times 2 gives me 12. And finally, I need a 3 over 3. So this is really the same as 20/12 plus 70/12 plus, and what's 13 times 3? 39, right? 39/12. Okay, so now, right, they're all like fractions. I can add the numerators. So 20 plus 70 plus 39 is what? 90 plus 39 is 129 over 12. Let's see, can we simplify that? Yes, I think we can, but you know what? Let's convert that back into a mixed number first, and then we'll simplify if we need to at the very end, okay? So that's the answer, but it's an improper fraction, right? Because they gave us the original problem as mixed numbers, they probably want the answer and usually that'll be the case, as a mixed number, okay? So I need to convert this into a mixed number. Well, how do I do that? Just divide, right? So 129 divided by 12. 12 goes into 12 once. I multiply. So I subtract, right? That'll be 0. I bring down to 9. 12 goes into 9 0 times. I multiply 0 times 12 is 0. I subtract. And now my remainder is 9, right? So this is the same as 10 and 9/12. And then we find out, yeah, we can simplify the fraction piece, right? 9/12 looks like 3 goes into 9, 3 goes into 12. So this is going to be the same as 10 and 3/4. So this was really 10 and 3/4 when I convert it back to a mixed number. So that's going to be my answer here. Right, the answer is going to be 10 and 3/4. Okay, so, and you might find this to be an easier method. It's totally up to you. You can either work with them as mixed numbers when you add or subtract, or you could convert them to improper fractions first, work with them as fractions, and then go back, convert them back to a mixed number at the end. Okay, that's good for this section. That was quite a bit of information. So I'm going to stop there. And again, the next section, 2.4, we will discuss multiplying and dividing fractions, and also mixed numbers as well. Thanks.